In this video, we are going to look at how to find the slope when you're not given it. Previously, we looked at when you had an equation, how to determine the slope based on putting that equation solved for y, or what we call slope-intercept form. Some of what we talked about in that video we're going to rely on here to understand how it is we come up with slope when we're not given it. In all honesty, usually you're not given the equation. In a real-world situation, what you have is data, and you use the data to determine a slope of a line that models the behavior of the data. So usually we start with just data which shows up as ordered pairs or points on a graph. Even though that's the case, we're going to start with a line and kind of work backwards on how we would determine the slope from just a couple data points in order to create the equation itself. So what we have here is a basic line, which means it has a constant rate of change. And what we saw previously is that we can use the equation to kind of count off the slope, so to speak, in order to determine how the line is placed on the graph. But essentially, what we were doing in that video, we started with a y-intercept, and we counted to some other point on the line. It doesn't actually have to be on a grid line. Like, we could count off to this point, because there is a point there. That just won't be as accurate because we have to do some decimal approximations. So if we can, we try to land on exact grid lines, at least when we're trying to get our brains around the concept. So, and what we talked about previously is that what we're looking for is how far the x's change and how far the y's change. So here we have, to get from one of those points to the other, the x's are going to change by +3. So to get from this point to this point, the x's change by a +3 and the y's change by a +2. Now when we set that up in slope, we always put the change in y on the top, and on the bottom of the fraction we put the change in x. At first this just seems like a random assignment that you have to follow, but it is really how we think of rates in the real world. We express rates based on how much our outcome changes for how much we change the input, or the what we put into the situation. So we talk about miles per gallon. That's an output on top and an input on bottom. Change in output over the change in input. So here we said that our x's are changing by a +3, so that's going to go on the bottom, and our y's are changing by a +2, so that goes on the top. I always process my x's first and my y's second, just because that's how you count an ordered pair. So that kind of helps you stay in sync with that way of counting. But in the end, the y's have to go on top when we're talking about slope, and the x's have to go on bottom when you're talking about slope. So here we would say our slope, or we can abbreviate that as m, as we've seen previously, equals 2/3. So we could just say m equals 2/3. So if I had this line, if I just threw this line at you, you could determine the slope by counting off how much the y's change versus how much the x's change. Now again, we don't usually have lines just show up at our doorstep. What we usually do in mathematics is we go and collect data, which comes in the form of ordered pairs, and then we use the ordered pairs to determine a slope to approximate the behavior of the data, assuming the data is behaving linearly. So in that case, we wouldn't have a graph, and we wouldn't be able to just count things off. What we would have is ordered pairs. Now, our two ordered pairs here, the first one is the coordinates 0, 2, and the second one has the coordinates 3, 4. So we're going to go through the same thinking process, but just focusing on this idea that we only have ordered pairs and we don't have a graph to count off. Okay? But essentially, when we're looking at the graph, So when we determine the change in y's, essentially what we're doing is measuring the vertical distance between those 2 points. And to compute vertical distance without counting, what we do is subtract the difference between those values. Now over here in my problem, my y values are the 4 and 2. So to determine the distance between them, what I would do is just subtract the 2 of them. So it would be 4 minus 2. And that does equal 2, which is what we saw up here. But we'll get to that in a second. For now, we're just going to write that as if it's our top number. And then we'll talk about the bottom number. Again, that's going to be, let me change my highlighting here. That's going to be how much the x's change, but when we're talking about change in x's, we're talking about the change in a horizontal direction. So here our horizontal change, or distance between those 2 points, is 3 units. Now in terms of what's happening over here with the ordered pair, that's going to be the subtraction of the 2 ordered pairs. Now here, because one of those, the subtraction of the x values of the 2 ordered pairs. Since one of those is 0, it's almost boring, but it's not always going to be 0, as we'll look at here in a second. So then doing the math on those, we just get the 2/3 that we already knew, which this seems like overkill because we already got that off the graph. But again, I'm just leading you in the direction of seeing how to do that. So that's essentially what we do to determine the slope when we're given 2 ordered pairs, is we're going to subtract the y's on the top and the x's on the bottom. The thing is you have to be a little careful about how you line things up. When you're doing this, if we were to subtract, what I did here was I did the 4 and I subtracted off the 2. You could argue that, okay, why did I do it in that order? Why didn't I do the 2 and then subtract off the 4? And in all honesty, you can do it in any order. However, it's really important that whichever y you choose to go first, its x-partner has to also go first. So since I chose the 4 to go first here, when I subtracted, its x-partner also has to go first. So essentially, this is one of my ordered pairs. And then the other ordered pair is the second set. So while I can change the order, I have to change it for both of them. So the other way I could have done this problem is 2 minus 4 over 0 minus 3. And that's going to give me a -2 over a -3, but then a negative over a negative just reduces to a positive. So in the end, we get the same values. This is usually expressed with something called the slope formula, which is that m, or slope, equals y2 minus y1 over x2 minus x1. Don't let all the math notation get to you too much. Basically, these subscripts, the 2's, is saying that the things with a subscript of 2 come from the same order pair. So the thing with the subscript of 1 come from the same order pair. Now that we have that down, let's look at finding the slope when we're just given 2 order pairs and we don't even have a graph to reference. Alright, so here we're going to find the slope of the line that contains the points 0.2, -3.4 and -2.3, 5.6. So again, the way we do this is we're going to set it up as a fraction where we subtract our y values on top. So here my y values are the second coordinates. So I'll subtract those on top. So I got 5.6, and you have to be careful with the -3.4 because we're subtracting -3.4. So you end up with a double negative sign there because we're subtracting and the number is negative. So in the denominator, if we put the 5.6 first, we have to also put its partner first. So -2.3. And we're going to subtract the 0.2. Once you do that, you just do the math where we're going to use our double negative as a positive. So that gives us a 9 on top and a negative 2.5 on bottom. And then when I divide those, we get that it equals negative 3.6. And here I went ahead and divided my slope down to a decimal because I was working with decimals in the first place. Had I been working with integers in the first place, or whole numbers, I would have left it expressed as a fraction, unless it was like in an applied context where it meant money or something. But since I started with decimals here, I went ahead and divided my result down to decimals. Go ahead and give a few of these a try and see how you fare.